All right, guys. Welcome to ICP today. Obviously, I'm not in class today. We are going to be talking about ions forming. So Monday and Wednesday, we talked about ionic bonds, and ionic bonds are created when atoms transfer or steal electrons, forming ions. Now, a lot of elements on the periodic table can become ions at some point, and so knowing some of the more common ions that can form can be very useful later on in chemistry, especially if you go on and take normal chemistry or even take chemistry in college. So we're going to look at those ions forming. Now, there are kind of two ways that this happens. Okay, the first way happens on metals. All right, so if your element is a metal, that means it is going to be towards the left side of the left side of the periodic table. In particular, it is going to be to the left of that blue staircase. All right, those are our metals. Now, the metals, they are going to give away their valence electrons. And when they do this, they're going to become positively charged. Now, how many electrons they give away is going to be based on how many valence electrons they have. So you need to know how many valence electrons they have. All right. Now, if you remember, if compounds are in the first group, the first column, they have one valence electron. If they're in that second group, they're going to have two valence electrons. If they're in the 13th column, they're going to have three. If they're in that 14th column, they're going to have four, and then 5, 6, 7, 8. All right. Now, metals are going to give those away and become positively charged. So let's look at an example of that. Let's look at sodium. All right. So sodium, Na, is in column 1 on the periodic table. So you'll probably want to pull out a periodic table. You should already have one. If you've lost it, there are extra copies over to the side on those metal trays. All right, so sodium has one valence electron. All right, so it has one valence electron. Now, because sodium is on the left side, it's a metal. That means it's going to give away its valence electrons. Now, when it gives away its valence electrons, it's going to become positively charged. And the charge it has is going to be based on how many it gives away. And since it has only one to give away, it's going to form a +1 charge. Now, because it's positive, that means it's going to be known as a cation. Because remember, positively charged means cation. All right, so sodium, one valence electron, gives away because it's a metal, and so its charge is going to form +1 charge and therefore be known as a cation. Let's look at another example. Let's look at the element right next to sodium, Mg. So Mg is in column 2, which means it has 2 valence electrons. And because it's on the left side, it's a metal, which means it's going to give them away. And since it has 2 valence electrons, it's going to give away both. And when it gives away both, since it has 2 to give away, it's going to become a +2 charge. All right, so it's +2 because it had 2 valence electrons to give away, which means it's now going to be a cation as well. All right, so these are 2 examples of metals. The key thing here is metals give away their valence electrons, and their charge is going to be based on how many valence electrons they have. So if you have 1, it's +1. If you have 2, it's +2. All right, so let's look at a nonmetal. All right, if you see up here, nonmetals, instead of giving away electrons, they receive them. And when they receive those electrons, they become negatively charged. So let's look at the example of fluorine, element F. So element F is in column 17, which means it has 7 valence electrons. So it has 7 valence electrons. Now, because it's a nonmetal, it's going to receive more electrons. And remember, atoms are trying to get to the happy number of 8. So since it already has 7, in order to get to 8, it only has to receive 1 electron. And so since it's receiving 1 electron, its charge is going to be -1. All right, because anytime you receive electrons, you become negative, and it has to gain 1 electron to get to 8. So that means its charge is going to be -1. Now, because it's a negative charge, this would be known as an anion. All right, so that's fluorine. All right, let us do one more example to finish up today's lesson. Today's lesson obviously is going to be pretty short. So let's look at nitrogen. All right, so nitrogen is to the right side of that blue staircase, which means it's a nonmetal, and therefore it's going to receive electrons. So we can fill in this part real quick. Now, nitrogen, if you look on the big periodic table, is in group 15. So since it's in group 15, it has 5 valence electrons. Now, it has 5, and it needs to receive electrons because it's a nonmetal. So just think about this for a bit. If it's trying to receive electrons to get to the magic number 8, then how many does it need to receive? Well, hopefully you thought of 3, because in order to get to 8, it needs to receive 3. Therefore, its charge is going to be -3. And because it has a -3 charge, it's also going to be known as an anion. All right, so just kind of recap. Our metals, if you have a metal, they are going to give away, and however many valence electrons they have, that is the charge they are going to form, and it's going to be positive. Nonmetals are a little bit more difficult in that they receive electrons, and whatever they need to receive to get to 8 is going to tell you the charge. So if you have currently 7, you need to receive 1, so you have a -1 charge. If you currently have 5, you need to receive 3 in order to get to that magic 8 number, the octet rule. All right, so that is all there is today. If you got questions, ask a neighbor, try to figure things out. And I will be back on Monday, and we will continue on from Monday.